So be quiet. I'm going to record this, and we're recording now. So if you guys could be quiet and pay attention. I'm just going to go through some demos of each one of these examples.
there?
And my Mobi board isn't working, and so I'm just going to have to sit here and operate the mouse and stuff. So the first thing, if you have an angle with a vertex on the circle, if you have an angle with a vertex on a circle, this is called an inscribed angle. There's a relationship between the inscribed angle, which is right here, and its intercepted arc, which is this thing right here. What do you think that is?
Just like number one on the homework.
It's not just like number one, okay? So let's see if you can figure it out. As I drag this thing, notice that, so here is the arc AB from, actually the mark CD, sorry, which is this one right here. Very good. So this inscribed angle, that's your first conjecture. C60, okay? Inscribed angle, the measured angle inscribed in a circle is half the measure of the central angle. So if this central angle here, so down type, say this angle here is C, if this angle is 100 degrees, which, and I'm talking about 99.9 right here, this angle right here, if this angle is 100 degrees, right, then this angle here is half of that, which is 50.
So E would be,
Okay? So E would be 50. Yeah, CED, right? CED is half of the intercepted arc. Notice that? Okay? What? Half. Okay? When that angle, when this arc, which CD is about 60, then this is 30. And there's a way to prove that, which we'll talk about later. Okay? So if this is, so if this angle here is 55.92 FG, and going backwards, if this angle here is 56 degrees, how much would this arc be? About 120. I could do that. Watch.
Oh, I get it.
Watch. Measure arc length, which you could do. And oh, that's not what I want. Measure arc angle. Okay. Boom. 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 Measure arc angle. Oh, I didn't do it. I have to click on this, then this, then I think this. Measure arc angle, and it is about 121 degrees. So now I'm going backwards, right? If this angle is about 20, then this angle is about 40, right? It is exactly 40, and so forth. And there's a way geometrically to prove that by drawing in. The way you would do that is by drawing another. You would draw a triangle right here. Whoops. You would draw a triangle and you could prove it pretty easily, actually. Which will be. Okay. So that's the first conjecture. The next one, inscribed angles intercepting arcs conjecture. Got it? So let's see if I can find that one. Save changes? No. Okay. So inscribed angles. Where is that one? Same arc. Same arc. So here's another little intersecting the same arc. So if this inscribed angle and this inscribed angle both intercept the same arc, what would have to be true about this angle and this angle? They're the same. Do they both intercept the same arc?
they can.
Oh, they don't in this case. There.
Oh.
Now they intersect the same arc. Okay? That wasn't driving. So watch. So if this angle here, let's put labels on these angles. A, B, C, and A. That's okay. And we'll call this something else. And A, B, C is already good. So if I want to measure this, boom, 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 measure angle, right? And where is it? That's measure angle ABC, that's that angle right there. And I want to measure this angle, A, B, C, and I go measure angle. Those two things should be exactly the same because they both are half of this arc, right? So if they're both half of this arc, then they have to be the same, because that's the arc that they intersect. Any questions on that? So that is C61. Angles inscribed in a semicircle conjecture.
Wait, so what's
What? Inscribed angles inscribed angles that intersect the same arc are friends. No, congruent. Congruent. Got it? We're so smart. I'm so smart. I has that thumbs up? No, it does. So we're going to continue here with this one. Dropbox save changes? No. Okay. So now we're going to say intercepted arcs inscribed in a semicircle. So here's another one. What? I made all these. These are pretty good. So this is a angle that's inscribed in a semicircle. How many degrees in a semicircle?
Over 2, 180.
How many degrees in a semicircle? 180 degrees. So how much does this angle have to be? 90, right? Because it's always half of the intercepted arc. So if the intercepted arc, which is here, is 180, that angle, no matter where I drag it, is always going to be 90. Watch. There you go. Measure angle. So this angle ABC here is always 90, and it's kind of cool because I could drag this point, change the shape of that triangle, but this angle here is always going to be 90 degrees, as long as, because it's got to be half of 180. See that? Yes? Okay. And that's conjecture C62. C62 says that angles inscribed in a semicircle conjecture, angles inscribed in a semicircle are right angles, so 90 degree angles. Okay. Questions on that? Easy? Get it? Got it? Okay, next one, a cyclic quadrilateral. Cyclic, that's six. Okay, I'll show you. No. That's cyclic. Where's the cyclic? Do I have a cyclic? There we go. Okay? That's cyclic. Got it. So, think about this one. So this is called a cyclic quadrilateral. It's inscribed in all its vertices. Quadrilateral means four sides. So all its vertices are on the circle. So this is not necessarily true for any quadrilateral, but it appears that if I take this one, A, B, I would let you do this in the lab, but we don't have enough time. A, B, C, and what's true about A, B, C, and A, D, C? A, B, C, and A, D, C.
They equal 180.
They equal 180. Watch. Measure. Can I click on this? I could go measure. Where is it? Calculate. Number. Calculate. So this plus this. Okay. The angle opposite it is. Look at that. Always 180. Yes. Okay. So this angle ABC, which is this one right here, okay, and this angle CDA, which is this one right there, those are always going to be 180. And even if I change, you could, can you check the light here? You need to go to the restroom? Where are you going? Okay. So no matter how I drag this triangle, then those two have to add up to 180. The opposite angle in a cyclic quadrilateral always add up to 180, which is kind of cool, right?
Okay.
So, and this one here, angle A and angle C, also have to add up to 180. And the reason for that, look, if I were to cut this in half, right, say I were to go right from here to here, okay? How much is this piece plus this piece? 360. So this plus this has to be half of 360, so those have to add up to 180. Do you understand that? Hello? You understand why that works? Because whatever this angle is, it's half of this arc, yes? And whatever this angle is, it's half of this arc, and since those two arcs add up to 360, Those,
And then two angles.
yes, yeah, they both have to add up to 180. So, so that's, C63, cyclic quadrilateral. The opposite angles of a cyclic quadrilateral, I don't know if it's cyclic or cyclic, are
Search it up.
supplementary. We're not gonna search it, okay? We're not gonna look it up on the internet.
Yeah, Siri.
We're just gonna take my word for it. I just proved it. What do you want? No, Siri's not as planned. Okay. Here we go. So that's that one. Any questions? Go like this. You'll see. Okay. Good. Okay. Next one. Parallel. What? Yes, real. It's they struck it. Come on. Let's finish up. We're almost done. Okay. So, you guys, just chill. We're almost done here. Okay. This one talks about the parallel lines and intercepted arcs. Okay? So I can measure intercepted arcs. I'm going to show you this. This is kind of cool. By going like this, boom, 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 and go measure arc length this time. Okay? 257. Actually, measure arc angle. I could also measure. Oh, I can't do it. Boom, 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 measure arc. Wouldn't let me do that.
You're like, you need to click them.
Arc angle. It'll measure that angle. So that's this angle right here. Okay. Now this one right here. Measure arc angle. Okay. Notice that those two things, this angle here, and this length, if I measure the arc length, let's just do that, just to show you. What? Yeah, arc length. Notice that those two things are equivalent. And no matter how I drag this, okay, notice that as long as these lines are parallel, because when I constructed this, I constructed those lines parallel, what's got to be true about this piece, and those angles right there?
They're all the same.
They're congruent. And there's a reason for that as well, and I just want to show you. The only thing you'd have to do if you wanted to prove that is to put a line from here to here, okay? Because who can tell me why this arc angle has to be congruent to that arc angle? Very good, okay? Because these lines are parallel, which makes this angle here, right? This angle congruent to that angle, right? This angle and this angle are congruent, and this is half of this, right? And this is half of this. Therefore, this and this has to be congruent as well. Okay? Okay? So in the parallel lines intercept congruent arcs on a circle. Parallel lines intercept congruent arcs on a circle. And then, so if I go down and I look at this, let's look at this. It says given GH is parallel to IJ, measure of GHJ is 50, and measure of AB, what's AB? AB is GHJ is 50. Measure of AB, where's AB? I don't even see an AB. Find the measure of HG. Where's HG? I don't know what the
I
heck.
think you have to, I think AB is like HI to GH, and then you have to.
I don't know. Okay? But this is congruent to this. Anyway, it was an example I tried to make up that. So your homework is, you ready for your homework?
I'm ready.
Sophie is ready for your homework.
327.
Page 327,
1 through 10.
1 through 14,
Only 1 through 15, now that'd be good 12.
Page 327. So, your homework is page 327.
We have to draw the circles again.
Yeah.
No,
So,
now we're
so
doing
very
it.
short.
It's really just the way
We have to- Draw the
Can we
picture.
please not draw the picture?
Draw the,
Oh, my.
you don't have to,
You don't have to draw that.
Don't draw everything. How about that over right now? Let's draw all you need.